Let's do a couple of Check Your Learning 10.6. Let's look first of all at number 6. A bus travelling in a straight line accelerates from 60 to 100 kilometres an hour in 1 minute. Calculate the speed in metres per second. -2. Righto, so this is check 10.6, page 296. Righto, so what information is given to us in the question? A bus is travelling in a straight line, accelerates from 60 to 100 kilometres an hour. So I've got an initial velocity, this is number 6, initial velocity of 60 kilometres per hour and a final velocity of 100 kilometres per hour. And I have a time of 1 minute. Right, so before I start, I need to check that I've got the units, and I have not. So I need to change this to meters per second. And if you recall in the last video, I showed you how to work that out from first principles, but I've got to divide by 3.6. So 60 divided by 3.6 is 16.7 meters per second. And this one is 27.8 meters per second. And even the time in this question is not in the right units, so we need it in seconds. Now, the first equation of motion I wrote down was V equals U plus AT. Right, so I could substitute those things in there. That was actually derived from probably a simpler formula to use, which is acceleration is the change in velocity divided by the time that took place in. So that's final velocity minus initial velocity divided by time. So acceleration is V minus U divided by T. That's just that formula rearranged. But you can substitute straight into it. It's not going to matter. You're still going to get the same result. So 27.8 minus 16.7 divided by 60. What does that give us? 27.8 minus 60. What do we got? Can you see it? There you go, 0.165. And the unit for that will be meters per second squared. Now, bonus points, acceleration is a vector, so you should probably say, I don't know, along the road or something to show a direction. Or away from the viewer or something like that. Look at number 8. The head of a rattlesnake can accelerate at 50 meters per second squared when striking a victim. If a car could match that acceleration, calculate how many seconds it would take the car to reach that speed from rest. So I've got an acceleration given to me of 50 meters per second. I've got an initial velocity was set from rest, so 0 meters per second. Squared up there. The final velocity has to be, they just go on 27 meters per second, and it wants the time. So V equals U plus AT. So T equals, it'll be 27 minus 0 divided by 50. Which is, I don't know, I'm just not going to calculate it. It's approximately 0.5 seconds, about half a second. Whoa, I guess you'd be pushed back into your seat a bit. Question 9's a bit different. A car is moving at 30 meters per second and decelerates at a uniform rate of 1.5. So it's moving at the start, at 30 meters a second. And then it says it's decelerating at 1.5. Now there's a little hidden trick in that one. It's decelerating, so it must be negative. How many seconds will it take the car to stop? So we want to reach a final velocity of 0. And we want to find the time. And then it says, and how far? So we want S as well, the displacement. Rightio, so we're just going to use V equals U plus AT. 0 equals 30 plus negative 1.5 T. So when I rearrange that, I'll have negative 30 equals negative 1.5 T. So T is 30 over negative 1.5, which equals 2. So it's going to take 2 seconds. Oh, didn't have the camera in the right spot, sorry. Now I need S.